Question 3. So for part A, find the value of t at which A starts to decelerate. So this value of t, this is where it starts to decelerate. So really we're trying to work out the value of t here, which I'm calling x. Now v equals u plus at. We know our initial speed was 10. Our final speed is 8. We're decelerating at 5 meters per second squared, so that's an acceleration of -5, and we know the time taken is this length here, which is 2 minus x. So substituting that in, we get this. Working our way through the algebra, we can work out that x is 1.6 seconds. Now for part 2, we've just got to be careful here. So remember, the area under a velocity time graph is distance travelled. So so we're going to focus on the distance travelled by both athletes between 0 and 2. So for athlete B, well, that's easy. This is the area under the graph here, which is just a triangle. So it's a half times base of 2 times the half of 8. So the distance travelled by B in those 2 seconds is 8 meters. So I've represented that up here. B, 8 meters travelled in the 2 seconds. Now distance travelled by A. So this is this area here under the graph. Okay, from here to here to here to here to here. So this comprises a rectangle and a trapezium. So the rectangle has got a base of 1.6, because we've now worked out that x is 1.6, a base of 1.6 and a height of 10. So that rectangle is this bit. Now the trapezium, you remember how to work out an area of a trapezium, is the average of the two parallel sides. So a length of averaging 10 and 8. So 10 plus 8 over 2 times the depth of the trapezium, which is 0.4. So adding these two shapes together, we get a total area under the graph for A of 19.6 meters. So A travels 19.6 meters over the 2 seconds. Now we're told that B is 1 meter ahead of A at this point. So here we go, B is 1 meter ahead. So how far is what's the distance between A and B at the beginning of the 2 seconds? This length here. Well, it's 19.6. Take away 8 less a meter. 19.6 less 7, which is 12.6 meters.